Okay, this video is intended to understand some of the basics of Arduino analog to digital conversion, analog input, analog output. Um, and the way we'll do this is to look at the analog in-out serial sketch, which is shown over here. It's actually currently running, and I'll show you the setup of the Arduino Nano Every, which is what I'm using here for this experiment. It's set up on its own little breadboard here. I'm feeding 5 volts in from my analog discovery power supply. Those are going into the V in and then also to ground. So V in and ground are connected. And then as described in the sketch, the analog in-out serial Arduino sketch, but 5 volts comes into one side of a potentiometer. The center tap from the potentiometer goes into the analog pin A0, and then the other side of that potentiometer goes to ground. So basically we are using the potentiometer to vary the voltage into analog pin A0. The Arduino then converts that into a digital value internally, a 10-bit digital values from 0 to 1023, which is basically 5 millivolts per, or 1 count per 5 millivolts of voltage change. And then it sends the output on the other side to pin 9, D9. That's the analog output, which is a PWM signal, pulse wave modulated signal, which represents kind of the analog conversion of that input signal through the pot to the brightness of an LED. So they send an output PWM, which is basically a conversion from 0 to 1023 of voltage to 0 to 255 of a PWM signal, or the width of a PWM signal. I'm taking that PWM signal and putting it into my analog discovery scope channel 1. I'm also taking the voltage, that is the value that's feeding into the Arduino, into my scope channel 4. So I'm basically looking at the input to the Arduino and the output from the Arduino. The input being that voltage level from the pot, and the output being the PWM signal that lights up the LED and controls the brightness of the LED. All right, so I'm going to set my camera up here. What we're looking at, this is the sketch itself. It's called AnalogInOutSerial. It talks about setting up those analog input pins at A0, the output pin at which is basically D9 going to the LED, sets up some variables, establishes a serial communication bit rate of 9600 bps, and then makes some calls to get the value from the input pin, maps the value from that input pin from the range of 0 to 1023, that's that 10-bit value of the input signal, and then maps that to 0 to 255 on the output. Then it writes the output pin, the output value that has been mapped, and sends some data to the serial port to print out. And that's basically it. Then it delays for 2 milliseconds before doing it again, so it just keeps repeating that loop. I have the serial output here streaming, so we can see that. And as I turn this potentiometer, I'll turn it to 0. We get the sensor is now at 0. That's the values that can be anywhere from 0 to 1023. And the output value, which can be 0 to 255, is now at 0. So that mapping of 0 to 0 is there. And I'm going to turn this all the way up. And you can see the LED is out. I'm going to turn it all the way up. Brightness of the LED goes to maximum brightness. Sensor is now taken that voltage input and converted it to 1023, the maximum value, and that then maps to the 255, which is the output value from the Arduino, which is controlling the PWM output. And here what we're looking at is that PWM signal. That's the yellow. So we get those pulses. It's happening at a frequency of about 1 kilohertz. So every millisecond you get a pulse. The magnitude of the pulse is about 4.4 volts. And depending on how I turn this potentiometer, you get a narrower or wider pulse. The green line is the value of the voltage that's coming out of that potentiometer. So if I turn it all the way down to 0, then we get a pulse wave modulation signal that is minimum, right? Minimum width. As I turn it up, and you can see the voltage coming up, that's the voltage out of the potentiometer. Let's say we'll go to 1 volt, which is 20% of 5 volts. We get a pulse width, a duty cycle of 21%. So it doesn't map perfectly, so there are some errors in the conversion to the 1023 values, but it's pretty close. And now if I bring that up to, say, 2.5 volts, I can read that right here in the C4. 2.5 is half of 5, so we should get a duty cycle of about 50%. We're getting a duty cycle of 52%. Half of 1024 is 512, so I'll turn that down to 512 over here. And let's see, 512, thereabouts. You should get 128 over here. So that mapping is pretty close. And now we've got a duty cycle of 49.9, the 50% duty cycle. Yeah, the voltage doesn't map right. The voltage is actually a 2.3 rather than a 2.5. But that's probably just in some errors in the device's analog to digital conversion. So that's it. If we take it all the way up and we get a 100% duty cycle, full brightness on the LED. And as we turn it down, the LED brightness goes down. As the pulse width modulation is reduced till we get to 0, and it's minimized. So that's it. That's visualizing the AnalogInOutSerial Arduino sketch using the Arduino, what is it, Nano Every, right. So that's it. Thank you for watching.